Hello. Today we're going to talk about 4.2 standard form of quadratics. So, standard form of a parabola. So, that is in the form y equals ax squared plus bx plus c. Okay, so this is not in your vertex form. So, knowing your vertex right away isn't a thing. You don't see those parentheses and you see x squared and x. So when you see both x squared and x, know that's standard form. So then we got to do some fancy footwork, well, fancy pen work, I guess, to figure out our vertex. So to find our vertex, now again, your vertex is always h comma k. So h is negative b over 2a. So b is 8, so negative 8 over 2 times 2. So h is just negative 2, right? Negative 8 divided by 4. So here, our vertex, we've got the x coordinate, but now we need the y coordinate. So how do we get that? We plug it in. So y, which is also our k in this case, is going to be 2 times negative 2 squared plus 8 times negative 2 minus 2. So 2 times 4. Well, I guess I could just go ahead and multiply that out. Oh, it's loading. So now we get 8 minus 18. So we get negative 10. So our vertex is at negative 2, negative 10. Okay? So here, our vertex, we can go ahead and put that answer in. And now my scale is way off, so I'm going to rescale this and do these by 2s. That's going to be 2, 4, negative 6, 8, 10. This is going to be 2, 4, 6, 8, 10. So, let's see. Sorry, realized my scales were way off. So this is also going to be 10. So I'm just going to do these by 2s. So, negative 2, negative 10 is our vertex. Our axis of symmetry has to go through that vertex. And since A is positive, we know it's going to go up. So let's see. Might be easier just to plug things in. But your other values should be... Give me a second. Leave should be here. Okay, now that I've got my vertex and 2 points to the left, 2 points to the right, we've got enough points. So we graph it. I go from edge to edge, try to hit your points. Ooh, went a little off there. Okay, close enough. All right, so since it's a smiley face, it's going to be a minimum. The minimum is going to be negative 10. The domain is your x values. So look at it from left to right. So it's going to keep going left, it's going to keep going right. So my x's can be anything. So here we can just say all reals, or we can use interval notation, negative infinity to infinity. All right, or we can use inequality notation. So negative infinity is less than x is less than infinity. All right, the range is your y values, so going up and down. So it looks like it's every y value, except if we keep going further south, down here, there's no values. So the lowest it can be is negative 10, so since it has a minimum, y must be bigger or equal to that value. So y is greater than or equal to negative 10. Oh, here, let me put this in the right format next to each other. So if we say it as an inequality, y is greater than or equal to negative 10, or in interval notation, we're going from negative 10 to infinity. I personally prefer interval notation, right? It's much easier to write out than finding all those inequalities. All right, let's do some more. Oh, I skipped one. Okay. So let's go ahead and start by finding our vertex. So we're going to do our h is negative b over 2a. So negative 2 over 2 times negative 1, so we get 1. So our vertex is 1 comma what? So to get our k, we plug it in. So you square it, then multiply by negative, so we get negative 1 plus 2 minus 5. So we should get negative 4 for our k value. So our vertex is 1 comma negative 4. And it has a negative a value, so we know it's going to be going down like this. So this is just a sketch for us to see it a little better. So our vertex is 1 comma negative 4. Our axis of symmetry is x equals 1. It's going to have a maximum, so max, of negative 4. The domain for any parabola is going to be from negative infinity to infinity. And the range, since it has a maximum, that means it has a top-off point. So we have to go from negative infinity to that value. So if you wanted to write it as an inequality, you would say y is less than or equal to negative 4. So maximum is less than. Okay, and again, you can plug this into your calculator. So I'll do blue as my parent function. Okay, good. Red is going to be this equation, so I'll type it in. So we'll do negative x squared plus 2x minus 5. And we graph it. So the blue, again, is my parent function. And the red graph that's coming up, there we go, is my parent function. I mean, my new function. Okay. So that looks about right. Okay, so if I want to trace it, again, scroll down to get to the right one, that my red one is the right one. As you can see, I can press in, 1, and I get negative 4, which was my vertex. So let's see. Again, I don't know if this is a good thing or a bad thing, but I'm about to show you how to find that maximum with your calculator. So we do something called second trace, and you can find all these valuable things. So we can find a certain value, we can find the zeros, minimums, maximums, intersections, all this fun stuff. So this is a maximum, so I'm going to go down to a maximum, hit enter. I want to do my red equation, so I'm going to go down and select red. Now it says left bound, so select a point that's left of your maximum. So that's left, so I'm going to pick that one. Then pick right bound. So I'm going to pick something to the right of it. And then it says guess. So let's see. There is my guess. And it gave me, now see here, it was a little bit off. Alright, but it was close. It's probably because I didn't pick it close enough. You know, the closer left bound and right bound that you get, the better off you are. So here we can see Okay, it looks like we did the right thing. Okay. So hopefully that helps you in double checking your work and not just doing it for you. Okay, because that's not going to help you. So let's do some more. So negative b over 2a. So this one is a little weird, so I'm going to write this one a little different. All right, we're missing our x value. So we could insert one by saying 0x. So then our h is negative b over 2a. So negative 0 over 2 times negative 2. So it's just 0. So our vertex is at 0, comma what? Gotta plug it in. So I plug in 0 for x, and I should get 3. Now, that was the long way of getting it because it's actually in vertex form. Okay? You could look at it in two different ways. That was in standard form if I put a 0 there, but I could also rewrite it like this, and now it's in vertex form. Okay? So it just depends on how you see it, but both ways of solving are going to get you the same answer. Okay? Both ways are correct. So let's see, now that we have our vertex, it's 0, comma 3. Let's see, it didn't say to sketch it. Remember, these are the things I'm looking for. So I like to just get a visual. So if we're at 0, comma 3, well then notice it's a negative a value. So I know that's going to go down. So my axis of symmetry is x equals 0. I know it's going to have a maximum at 3. The domain is going to be all reals. And my range is going to cap off at 3, so negative infinity to 3. Okay, so I just did the graph here just so I could visually see that it was a maximum. Okay, let me walk you through it again. One more time. So let's find our h. So negative b over 2a. So negative 2 over 2 times negative 1. So we get 1. So let's see, we're halfway to finding our vertex. So find k by plugging in 1. And let's see, we should get 6. So we get 1, comma 6, we're way up here, but a is negative, so I know it's going down. So vertex 1, comma 6, axis symmetry is x equals 1. It's a maximum at 6. Domain is always all reals. Ooh. And our range caps off at 6, so it's going to go from negative infinity to 6 with a bracket on 6 because remember it actually hits 6. It can't hit infinity, so it's a parentheses. Okay? So hopefully graphing standard form makes sense. Okay? All else fails, I always just convert it to vertex form, right? I don't like standard form. You know, standard really is misleading. I guess that's polynomial form, that's easy to type form, but other than that, vertex form is a lot more useful. So if you want to convert this, here you have x minus 1 squared plus 6, right? Our vertex was negative 1 and 6, and our a value is the same a that was there. So if that was a negative, this is a negative. All right, a value is the same. Got any questions? Come talk to me in class.